Hello everyone. Today we're going to be learning Introduction to Inequalities. We're going to be learning inequalities. Now, to learn inequalities, you first need to know the inequality signs. So by inequality, we mean that they're unequal or not equal. Right? So either one's going to be bigger, the other one's going to be smaller. And when we say inequality, we actually do include cases when they are equal. So let me just show you all the different cases that we'll be covering in this section. So this is a sign that we use for inequality. When we say x equals y, this means that x is equal to y. So this is equality, right? The two quantities are equal. But when we say x is greater than y, or this sign here means that x is bigger than y. Okay, that's what that sign means. And we have this sign which goes the other way. This means that x is smaller than y. And we have something like this. This means that x is bigger or equal to y. And lastly, this one means that x is smaller than or equal to y. Okay, so if you're having trouble remembering which one means greater than and which one is less than, just remember that this sign always opens up towards the larger number. So this means that x is larger. This means that y is larger. This means that x is larger or equal to. This means y is larger or equal to. Okay, so let me write down a few cases using these inequality signs, and you can think whether that's true or not. So the first one would be this one. Is this true? Or first of all, what is this saying? This is saying that 3 is bigger than 5. Is that true? Well, we know that 3 is not bigger than 5, right? So that means this side is not bigger. This inequality is saying that that side's bigger, but this is not bigger, so this would be false. This is not true. How about 4 is greater than 4? Is this true? Is 4 bigger than 4? 4 is not bigger than 4. 4 and 4 are the same thing, right? They're actually equal to each other. So this is, again, false. But notice, if I change the inequality sign to this, this is now saying that 4 is bigger or equal to 4. Is this true? Well, 4 is not bigger than 4, but it is equal to 4. Okay, so because of that equality sign in the bottom, this would be true. Okay, so that's the difference between just using bigger than or less than and using bigger than or equal to or less than or equal to. Okay, let's try one more example here. 5 is less than 7. Would this be true? Saying 5 is less than or smaller than 7. And we know that 5 is smaller than 7, so this would be true. Okay, now using these inequality signs, let's try to apply that in algebra. So for example, let's say that we have 3x is less than or equal to x plus 3. Or why don't we use x plus 6 here? Okay, now tell me if this is true when x equals 0, when x equals 1, when x equals 3, and when x equals 10. Okay, so we are considering 4 different cases. So first of all, when x equals 0, the left side is going to be 3 times 0, less than or equal to 0 plus 6. Right? We're just substituting 0 for x. Now that would be the left side is going to be 0. 3 times 0 is 0. The right side, 0 plus 6 is 6. So this is saying that 0 is less than or equal to 6. Is that true? Well, 0 is less than 6. Okay, so that means it's true. Let's try when x equals 1. Then we'll have 3 times 1 on this side, and 1 plus 6 on the other side. And the left side is going to be 3. 3 times 1 is 3. The right side is going to be 7. And we're going to get 7 is less than or equal to, or 3 is less than or equal to 7. Is that true? Well, 3 is less than 7. So again, that is true. And third case here, we have 3 times 3 on the left, less than or equal to 3 plus 6. On the left side, we have 9. 3 times 3 is 9. On the right side, we also have 9. 3 plus 6 is 9. And it's saying 9 is less than or equal to 9. Is that true? Well, 9 is not less than 9, but it is equal to 9. So because of that equality sign, this is still true. Okay, and lastly, I'll have, 3 times 10 on the left side is less than or equal to 10 plus 6 on the right side. On the left side, I'm going to have 30. 3 times 10 is 30. Right side is 16. Is 30 less than or equal to 16? Well, 30 is not less than 16, and it's also not equal to 16. So the last one here would be false. Okay, so we have 4 different answers for our 4 different cases here. Okay, so that's how we can evaluate inequalities. Okay, we can plug in the numbers for x and then see if the inequality is true or not. Okay, now I want to show you how to visualize the inequalities. Okay, so in other words, we'll be plotting or graphing inequalities. So for example, let's say we have this inequality here, x is greater than 3. Okay, so we can think of different values of x, right? That would make this true. For example, if x is 4, then this will be true, right? 4 is greater than 3. If x is 5, this is also going to be true. If x is 6, it's also going to be true. But if x is 1, it's not going to be true. So we want to have a more visual way to see all the possible solutions for this inequality here. Okay, so the way you do that is you use a number line Okay, we start with 0, and then we have 1, 2, 3, 4 this way, and then the other side we're going to have negative numbers. Okay, and then circle this number on the number line. This number right here. So it's going to be 3. Actually, let's add a few more numbers here. And x is greater than 3. Does that mean that the numbers on this side is true, or the numbers on that side is true? Well, the numbers that are greater than 3, remember this is the greater than sign, the numbers greater than 3 is on this side. So that means we circle, actually I should have used a different color for this circle here. Okay, you circle the number 3, and then you draw an arrow going this way. So this means that all the numbers that are on this side, that are on the blue arrow, is going to make this equation true. So that's why 4 was true. That's why 5 was true, because they're all on this side. But 1 was not true because the 1 is on the other side of that arrow. Right? So when we graph the inequality like this, you can kind of see, visualize all the possible numbers that will make that inequality true. Okay, let's try another case here. X is less than 4. Okay, again, let's draw a number line for this. 0, 1, 2, 3, 4, 5 on this side, and negative numbers on the other side. Okay, so again, circle this number. It's 4 this time. And which way should the arrow go this time? This time x is smaller than 4. Right? X is smaller than 4. So it's going to be the numbers on this side. The smaller numbers. Okay, so this is how you can graph the inequality. And you can check, just plug in any number on that side. So let's say 2. If you plug in any number, is that true? 2 is less than 4. Is that true? Yeah, 2 is less than 4. So that is true. So that means you have graphed this correctly. And if you try to put a point on the other side, for example 5, then it's not going to be true. 5 is not less than 4. Now one another case where we have equal to. So let's say that instead of x is less than 4, let's say we have less than or equal to 4. How would you graph this one? You will graph this exactly the same way, except for one little difference. So you will circle at the 4, and then you'll still draw the arrow this way, because it's less than, but you will color in that circle. So in this case, don't color in the circles in this case because they are not equal. But in this case, they are equal. So you color in that point there. And this means that 4 is also included in the solution. So if you put a 4 here, it's also true. Whereas if you put a 4 here, it's not true. 4 is not less than 4. So that's why we didn't color in the 4 here. Okay, and similarly, if you were to consider the or equal to version of this one, if it was 3 is greater than or equal to 3, then 1, 2, 3, then you will circle in the 3 and then draw the arrow this way. Okay, so the only difference of having the equal sign and not having that equal sign would be that you will color in that number if there is an equal sign, and you leave it open like this if there is not an equal sign underneath.